We're going to talk about portfolio theory. Okay? Portfolio is a collection of many different investments into one basket, right? So, well, what's the reason to make a portfolio instead of putting all your money in one investment, whichever you consider the best? What's the reason that you would combine, right, many different investments into one basket? Well, the thing is, you can diversify. When you diversify your investment, you can reduce the risk, right? That's the primary reason for combining many different investments into a portfolio. Okay, so most of today's class will be devoted to understanding portfolios, how to calculate the risk and how to calculate the return, how to maximize the return, how to minimize the risk, and so on. Okay. You don't have this on your notes. I got this directly out of your textbook. Okay, so don't try to find it on your notes. Okay. All right. So this just gives the idea about the portfolio, the reason why or how we can minimize the risk or reduce the risk. Okay? So the idea is, according to the textbook, this is the expected rate of return from an aluminum company. Okay? They use the example of Alcoa, Aluminum Company of America. Okay? But it can be any company, any item. Okay? So over time, you expect the return to go up and down and up and down and so on, right? So you can think about if you have this kind of fluctuation in expected return, okay, then you can think about, or the actual return, then you can think about expected returns, which is average, okay? Last class we talked about considering the probability, right? Expected return is summation of R, J, P, J, if you remember, right? So for different situations, whether it could be a recession or normal time or boom, and we can think about different probabilities for each probability for each situation. And we can multiply the return, expected return for, say, recession with the probability for the recession, plus expected return during the normal time, multiplied by the probability of normal time, and so on, right? So we're talking about this expected return or average, okay, return, right? But then we can also think about variability, how much variability there is, okay, in these returns, right? So we can say that standard deviation or sigma, and that's what we mean by risk in finance, variability or uncertainty, okay? All right, so we have, say, aluminum business to have high return or low return and so on, right? And the story goes that this company is thinking about diversifying into another business, getting into another business, which is gold mining. Okay? So you can say this is aluminum is pro-cyclical or cyclical. Cyclical or pro-cyclical means return goes up when the economy improves. We're talking about business cycle, okay? But when the economy goes down, when the economy goes into a recession, right, then the return from aluminum can go down, right? Which is quite plausible, right? Because whatever products that use aluminum, right, maybe airplane manufacturing or the beer can or soda cans and so on, right? The demand for aluminum will probably increase if the economy is strong, right? But it will go down when the economy goes into recession, right? But we can also think about some items that are counter-cyclical. Counter-cyclical. Counter-cyclical means this item changes in the opposite way. Okay? So when the economy goes up, the sales and return from this item goes down. When the economy goes into a recession, then the demand for this item increases. Okay? So this opposite direction from the pro-cyclical business. Okay? And they use the example of gold mining here. Why? Why do you think gold mining can be counter-cyclical? If you can remember something from your macroeconomics class. Or any investment, I guess, concept, right? What's true about gold? Substitutes, okay. You mean, yeah, well, it preserves the value, okay? So when the economy goes down, right, people, instead of putting money in the stocks or bonds or those things, they tend to put their money in gold, right? Because the value of gold tend to be stable, right? So when the economy goes down, right, the demand for gold increases. That's this case, right? This was the case of recession when the return from aluminum goes down. But if you invest in gold, then at that time the demand and price and return from gold can actually increase. Okay? All right. So what happens if you put them together, right? If this is the returns you expect from aluminum, right? And if this is okay, if yellow line stands for gold, right? Then when you add them up, right, the average can be pretty much stable, right? That's the third graph here, right? That's the idea of diversification, illustration of diversification and risk reduction, right? So the idea of, I guess, one thing you can get it from here is you have to find some items that move in opposite direction, okay? And that brings us to the next slide. Okay? So that's the idea of correlation. Okay? We need to understand the concept of correlation. Or more exactly, correlation coefficient. Okay? The full name is Carl Pearson product moment correlation coefficient. Carl Pearson. Carl Pearson, he was as a famous statistician, okay? And he came up with this idea of correlation coefficient, okay? He designed the correlation coefficient. We typically use R, okay? In our textbook we use rho, so we're going to use Greek letter rho, okay? And rho is somewhere between -1 and +1. The maximum value it can take is +1, and minimum number it can take is -1, okay? And the actual calculation or formula for correlation coefficient is designed such that if you have any straight linear relationship like this, right, or positive correlation, when the x, see, whatever you put on the x-axis increases, if what's on the y-axis also increases in a straight linear fashion, then rho will be equal to +1, okay? So it measures measures the strength, well, measures the direction and strength of linear relationship. That's what the correlation coefficient measures, right? So if you have positive sign, we're talking about positive correlation or direct relationship, okay? If you have relationship like this is a negative correlation, right? Negative straight linear correlation. Then when you calculate the correlation coefficient with these data points, you will get something like -1, okay? All right. So if you have some positive correlation, but that's not exactly a straight line, then you're going to have something between 0 and 1, some positive correlation coefficient. If you have some negative correlation, but not exactly a straight line, right, then it's going to be between -1 and 0, right? Have you guys learned this about correlation coefficient, right? If you haven't, then this is the topic of introduction to econometrics, right? If you take it next semester, right? Anyway, so if you have something like this, the third graph like this, in other words, you can't find really any linear correlation between x and y, right? Then the correlation coefficient will be pretty much 0. Okay? So based on the sign and magnitude of the correlation coefficient, you can figure out the direction and the strength of the relationship between the two variables. Okay? That's what the idea of correlation coefficient. Okay? So obviously, let's say what we're talking about here is two products that move in opposite direction. Okay? So what we're going to have is, let's say we have aluminum here and gold here. Okay? Whenever aluminum goes up, we want gold to go down. Okay? So we were looking for something like negative correlation. Okay? So if you can find two items with negative correlation, then you can reduce the risk, because when you add them up, right, between these two, they will cancel each other out, right? And we're going to have pretty much stable relationship, stable return, right? In other words, you can reduce the uncertainty, you can reduce the variability, which means risk is low. Okay? We'll get to that in a few minutes. Okay? So let's get on to how to measure the return on portfolio and also the risk of a portfolio. Okay? General formula of a portfolio, or expected return on a portfolio, is here. It is just a summation of Wj times Rj. Okay? Just like we used the formula for the calculating expected return for different situation, right? It's a similar idea. In a simplified case, if you have only two assets, A and B, right, then it's going to be simply a weighted average, okay? Weight of the first item, investment item, times the return from that item, plus weight of the second item, okay, times expected return from that item. Okay, so exactly just the weighted average. Okay, there's nothing special. All right. All right. In case of standard deviation, we have this formula. Okay. The general formula is a little bit complicated. So double summation Wi, Wj, rho ij, sigma I, sigma j, right? So what that means is, well, if you look at the two asset case, you can understand, right? That's the weight of the first investment squared times sigma of the first item squared plus the same thing for the second item plus 2 times WA, WB, rho AB. Rho AB is the correlation coefficient between the two items, A and B. Okay? So actually, sigma, what's sigma square? What do we call that? What's the square of standard deviation? Variance, right? All right. So sigma A square A here, this is variance of A, this is variance of B. And what we have here is rho AB times sigma sigma, right? This is actually in statistics covariance. Okay? What is the covariance? Well, the formula for variance is what? Summation of xi minus x bar square, or actually, let's use population, right? Over n. Okay? That's formula for variance, right? Formula for covariance is summation of xi minus x bar, yi minus y bar over n, right? Or, okay, let me change it to x bar here, using the sample, right? Well, in statistics, depending on whether you use population or sample, you can use either n or n minus 1, okay? But let's ignore that here. Suppose we can use entire population. Well, in finance, it is possible because, let's say you have the entire observation for a stock, right? Then you can do that. You can calculate the population variance or population standard deviation. For example, one of your questions in your project was to calculate the standard deviation for return, 3-year return, monthly return, right? So you're going to have 36 observations. That's in your entire population, right? So in that case, you have to use this formula instead of n minus 1. You have to divide it by 36, right? Instead of 35. Yeah? In other words, you're going to treat your entire data as the population. Okay? Anyway, so difference here and here is instead of xi minus x bar square, right? We're going to do x 1 times the deviation of x's and second time deviation of y's. Okay? So basically the same thing, except that instead of repeating this twice, right? Now we have x and y. That's what we call covariance. Okay? Covariance between x and y. Okay? Well, don't worry about it. So it's just as a side knowledge, side information. Okay? So this is variance, covariance. It might help you to remember that, the formula. Well, here's an example. So again, I took it from the textbook, so you don't have it in your notes, right? But why don't you open your textbook and follow through with me, okay? So here we have 7 different scenarios. Okay? First of all, security A in our textbook story is American Electric. Security A stands for American Electric Company, utility company. Okay? And according to the story, the return on A was, I believe, 12%. Okay? In other words, if you put your entire money into this particular stock, American Electric Utility Company, you could expect 12% return, right? And sigma was, I believe, 10%. Let me know if it's wrong. Right? The other stock, B, stands for Boeing. You know Boeing, right? The airplane manufacturer, right? And expected return from this stock was 16%, and sigma was 20%. Okay? So using these two particular stocks, let's think about what's going to happen to portfolio. Okay? Well, depends on weight of each stock. So the first line here says 0% for A, right? Which means 100% for B, right? So what if you put entire of your investment in Boeing stock? Then obviously the return will be 16%, right? Because Boeing stock has expected return of 16%. You can expect 16% return, right? What if you put 100% in American Electric, which means 0% in Boeing? And obviously the expected return would be 12%, okay, right? Well, the second line says 25% in A, which means 75% in B, right? So you can calculate it using the formula, right? The formula is expected return from portfolio is summation of WJ RJ, right? So 0.25 times, is that 0.25? Yeah, the second line is 0.25 in A, right? So 12 plus 0.75, 16. That's going to be 15%. Is that right? Okay. So that's how they calculated 15%. Expected return for this second line is 15%. And in case you put 1/3, 33%, 33.33% in A and 66.67% in B, it's going to be 14.67 and so on, right? So they thought about a few different scenarios here, okay, depending on different weight. And here's the graph, right? So if you put entire 100% in American 100% in American Electric, then expected return is 12%. If you put 100% in Boeing, expected return would be 16%, and the rest, the combination, these combinations are right on the straight line, okay? Because it's weighted average, okay? Make sure you understand the idea of this straight line, or the combination, or the expected returns would be found on the straight line, okay? Because I'm pretty sure you can remember from the high school geometry, right? If this is 2-to-1, and then this is 2-to-1, something like that, right? So that's the idea, yeah. All right. What about the risk? How do you calculate the risk? Risk formula was slightly more complicated, right? You have to use this formula, okay? But here, so if you go back to that formula, then what determines the portfolio risk is the risk level of each investment, A and B, and then also weight of each investment, A and B, WA and WB. Also, you have to also consider the correlation coefficient. Correlation coefficient matters when you determine the portfolio risk level. Okay? So here they thought about three different scenarios. The perfect positive correlation, meaning the correlation coefficient was 1.0. Absolutely no correlation, correlation coefficient being 0, right? And then perfect negative correlation. So correlation coefficient between A and B was -1, right? And then they thought about difference. I just took this part from previous table here, right? So we are talking about the first line corresponds to this weight, 0% for A. The last line corresponds to 100% for A, right? So based on that, they calculated, okay, right? So first scenario, what if rho was exactly 1.0, right? Then you can calculate all this, the risk level, right? Came up with 17.5 and so on, right? So if you want, you can try, let's see. Let's say for the second line from the bottom here, second line from the bottom, that would be 75% for A and 25% for B. Okay? So sigma P, the standard deviation for portfolio, would be 0.75 square 10 square plus 0.25 square times 20 square plus 2 times 0.75, 0.25, and rho, we assume that's exactly 1, right? And then 10, 20, okay? If you calculate that, you should get 12.5%. Okay, that's how they calculated this number. This number 12.5, right? So that's based on 75% on A and correlation coefficient of 1. Okay? All right. So that's this case. Again, because correlation coefficient was exactly 1, right? The different weight will have result in different risk level, right? But that will be exactly on a straight line, okay? There's nothing but the weighted average, okay? So this second dot here is 12.5% and the return of 13%, I believe, right? Yeah, return was 13% and the risk was came out to be 12.5%. So that's what we have here at this point, right? 13% return and 12.5% risk, right? All right, the important graph starts from the next graph here. What if we had no correlation between A and B? So in the first case, perfect correlation, which that means what? What's the story? If rho happens to be positive 1, perfect positive correlation, right? Then what kind of relationship do we have between A and B? Depends on what? No, I'm talking about, this relationship between A and this is A and this is B, right? And we found out the correlation coefficient between A and B was exactly positive 1, right? What does that mean? What? What do you mean by perfect positive correlation? Okay, if A, return on A goes up by 10%, right, return on B also goes up by 10%, exactly, right? If the return on A goes down by 5%, then return on B also goes down by 5%. Basically, they are changing together, right? Absolutely no difference, right? So that's exactly why this thing happens, right? There is no minimizing the risk, right? It's simply the weighted average between A and B. just depending on the distance. Again, distance being the weight, right? How much money you put in A and B, right? It's exactly the straight line, straight linear relationship, right? So what that means is, well, if you want higher return, you have to take higher risk, right? That's simple as that, right? That's the principle. That's the general rule, right? And portfolio didn't change anything, right? That's the idea of this straight line. Okay? But in the second case, if there was absolutely no correlation between A and B, see what happens. Okay? So for example, the second point here used to be 13% return and 12.5% risk, right? But this time, if you combine A and B, and more exactly, if you put 75% in A and 25% in B, then you can still make 13% return on your money, right? Sorry. Okay. But risk level is much lower. Risk level was 12.5%. Now the risk level is something like, 9% here, right? Make sure you understand that, right? So I put this blue line here myself, right, to compare with this line, okay? So compared to this blue line, all these combinations of two stocks have lower risk, okay? While maintaining the same level of return, you can reduce the risk by combining the two stocks. That's the idea of this curve. Does it make sense? Okay. More salient example is here. If you look at the third case, right? What if A and B had perfectly negative correlation, right? Perfectly opposite relationship. In other words, what that means is if A return goes up by 10%, B return goes down by 10%. Exactly, right? If return on A goes up by 5%, return on B goes down by 5%, right? Perfectly opposite relationship. Then we can completely eliminate the risk. You know this idea, right? If let's say blue stock goes like this, okay? And red stock goes totally opposite, like that, right? Then when you add them up, you're going to get exact straight line, right? When you add them up, the average will be exact horizontal straight line. In other words, variability will be 0, right? All right? So that's the idea of negative correlation, right? So depending on the weight, and here what that happens when the third line from the bottom, which is, okay. Yeah, if you put 2/3 of your money in A and 1/3 of your money in B, right? Then you could completely eliminate the risk. The sigma turns out to be 0, right? So that's the idea of this graph, right? That happens right here. So that's the idea of portfolio, right? You can combine multiple stocks or multiple items into your portfolio, and you can reduce the risk while generating the same return, right? And the important thing is the correlation coefficient. You have to find the correlation coefficient between different stocks, right? Well, if you can find something that is exactly -1, then you can completely eliminate the risk, but that's probably unlikely, right? I don't think you can find any stock which has perfect negative correlation, okay? But the important thing is as long as rho is less than 1, right, you achieve some risk reduction, okay? If rho happens to be exactly 1, then there is absolutely no risk reduction, because again, A and B is changing absolutely together, right? You might as well put all your money in one stock, right? So there's no point in dividing your money in A and B, right? But as long as they don't have perfect positive correlation, portfolio reduces the risk. Portfolio can reduce the risk. Right? That's the idea, okay? All right, so at this point, why don't we have some exercise? An efficient portfolio means for a given sigma, for a given level of risk, there is no other portfolio with higher expected return, R hat, right? Or for a given R hat or expected return, there is no other, you can finish the rest, right? No other portfolio with lower sigma, right? If these conditions are satisfied, right, then we say this portfolio is efficient. Okay? So we have, it's going, okay. All right, so we have this graph here. We put return, expected return on the vertical axis and risk sigma on the horizontal axis. And let's say we have 3 different portfolios, A, B, C, right? All right, let me read again. For a given sigma, there is no other portfolio with higher R hat, higher return, right? Or for a given return, there is no other portfolio with lower sigma, lower risk, right? Or you can put it this way. An efficient portfolio has the highest possible return for a given sigma. So let's say sigma level is here, right? Then we have 2 portfolios, A and B, that have the same level of risk, but B is not efficient, right? Because there is another portfolio with higher return. Okay? Makes sense, right? How about C and B? C and B share the same level of return, right? But B is not efficient. Only C is efficient because B has another portfolio with lower risk, right? Here, for a given return, there is no other portfolio with lower sigma, right? But between B and C, for a given return, right? B has another portfolio with the lower sigma. So B is not efficient, right? So both A and C are efficient, right? Make sure you understand that. Okay? In microeconomics, you probably had the similar concept, right? But when you learned about utilities concept, right? So more exactly, here's the typical graph that we use, right? Let's say we have all these dots. All these dots are portfolios, right? There can be many different portfolios, combination of all kinds of securities, right? And each portfolio has some level of risk and some level of return, right? And then only those portfolios on this frontier connecting point A and point B, this curve right here, right? That's the frontier for efficient portfolios, right? So if you have any point right here, right, that's efficient because there is no other portfolio that has higher return while maintaining the same risk, right? Or there is no other portfolio, you can't find any other portfolio with a higher return for the same, or lower risk for the same return, right? So all the combinations of portfolios inside are not efficient, right? Only those portfolios on the frontier are efficient, right? Oh, between A and B. If you have any point here, any combination here, it's not going to be efficient. You know why? Right? Because this combination here and here will have the same risk, right? But this combination has higher return. Okay? So only from A to B is the area or the circumference, right, where you can find the efficient portfolios. Okay? All right, that's fine. So make sure you understand that graph. Now we are getting into capital market line concept. Okay? So again, coming from this graph, we have expected returns on the vertical axis and standard deviation on the horizontal axis. And let's say we can find risk-free rate, RF. RF is a risk-free rate of return. What do you mean by that, risk-free rate? What's an example of risk-free rate of return? T-bill, okay. Right, treasury bill, okay. Or in the case of Korea, I guess 3 months 국고채, the government bond with the shortest maturity. I believe 3 months is I don't know exactly about the Korean case, right? But let's say you can find the shortest maturity treasury bill or government bond, right? And let's say that's 6%. It's a little too high. That's 3%, okay? Currently, let's say 3 months T-bill pays 3%, right? Then we call that RF, risk-free return, right? Well, we consider that probability of U.S. government going bankruptcy in 3 months is probably 0, right? Highly unlikely, right? Well, so that's why we use, right? All right. So if you put all your money in 3 months treasury bill, right, then you can make 3% return, right? What's the risk? What's the standard deviation? 0, okay? So that's right here at this point. At this point, return will be RF, but the sigma would be 0, right? This is a 0 origin, okay? Or let's think about, let's say we can find another investment, right? It doesn't have to be this M here. It could be any investment on the frontier, right? The efficient frontier right here, let's say. Let me, so we have RF here. And let's say we have efficiency frontier going like that, okay? And any portfolio is efficient. I mean, between, let's say, A and CB. Make it a little, okay? So what I'm saying by any portfolio is good, is okay, right? What I'm saying is all the combinations are efficient, right? Because you have to have the trade-off between risk and return. If you want high return, then you have to allow high risk, right? So you cannot say, if you have C and D here, right? You cannot really say C is better than D in terms of efficiency. They're both efficient, okay? It just depends on the person's preference, investor's preference, right? What's the difference between A and B, other than A and B are both efficient, right? I said A and B are both efficient, right? But what's the difference? Is there any difference between A and B? Think about yourself, right? If you are this investor, would you invest in A or B? Some say A, some say B here, right? What's the difference? Risk preference, okay? In other words, how much risk are you willing to take, right? Obviously, if you take higher risk, you can expect higher return, right? But do you have a stomach for that, right? Can you take that much risk, right? Well, I think you guys are pretty young, right? So you can lose everything and start over again, right? But a person like me will probably choose A, right? If you lose everything, it's going to be pretty tough to regain, right? So, you know, the person with more risk aversion, stronger risk aversion, will probably choose something closer to A, right? A person who can take more risk or was willing to take more risk, right, will take something closer to B, right? So let's say I draw a line something like this. Okay, here. I would say combination X, combination Y. Okay? And again, X and Y are both efficient, right? Nothing wrong with taking any of those, right? If you're, let's say, have another combination Z, right? If you say you're going to put your money in Z, then I would say, think again, right? You shouldn't do that. Why? Because this is not efficient. In other words, while taking the same amount of risk, you can definitely get higher return, right? Or while getting the same return, you can reduce the risk level, right? So Z is out of the question, but there's nothing wrong between X and Y, right? So you can do that, right? So if you put all your money in this combination, let's say combination X involves, let's say, two stocks. What's that? Apple and AT&T. That's fine, right? If you put 100% of your money in X, right, then you have to consider, you have to be ready to take some risk, right? Or if you really want to minimize or completely eliminate the risk, then you can put all your money in T-bill, right? And of course, your return will be much lower, right? But at least you don't have to worry about losing any money. Okay, right? So that's the idea, right? Or if you want, you can take the middle, let's say here, combination Q. What can you say about the combination Q? Let's say that's exactly midpoint between this point and X combination, X portfolio X. Is it possible? No? How is it possible? Is it possible that you invest? In other words, let's say this was 3%, this was 6%, okay? And this was 10%, and this was, of course, 0, right? So can you find the combination of combination of securities that will give you 5% risk and 4.5% return? How can you achieve that? Any idea? If that really suits your purpose and your taste, right? I really like 4.5% return and about 5% risk. Is it possible to do that? How? At exactly same weight. because you're talking about right in the middle here, right? So if you put 50% of your money in this portfolio and 50% of the money in T-bill, you're going to be right here, right? Make sure you understand that idea. Okay? Good. So with that understanding, now we can introduce another concept here, right? So based on this graph, what looks like to be your best choice or optimal combination, optimal portfolio? Any idea? Here's a hint, right? Think about this slope, right? What does this mean, the slope? Mm-hmm. Okay, right. So the slope here, slope of this line, right, is, if you think about any combination, let's say Rx, okay, okay, that had to be from here. Think about this point, let's say combination O and combination X. Think about combination O and combination X, or portfolio O, which is 100% T-bill portfolio, right? And this is, well, some stock portfolio, right? So return on X portfolio minus return on O, which is RF, divided by this sigma for X, okay? And let's say that happens to be, say, 1.2. Tell me, what is 1.2? Try to interpret that number, 1.2. If you what? You know that. You know the answer. Just slow down. You know the concept of slope, right? Slope is change in y over change in x, right? So that's change in x, and that's change in y, right? Just verbalize it, right? What does that mean if it's 1.2? For every 1% risk you take, right, your return increases by 1.2%, right? Make sure you understand that concept here. The slope is the ratio between this return and risk, right? If it's 1.2, that means for every 1% additional risk you take, you can expect 1.2% increase in your return, okay? So obviously, it's higher the better. If you're going to take more risk, you might as well get more return, right? So instead of doing X or Y, what should you do? Instead of investing your money in X or Y, you should try to make it steeper, okay? And when can you achieve the steepest slope? In other words, tangency, right? Like this, right? When the line is just touching that curve, right here, right? We're talking about this white line I drew here is somewhere like here, right? It's passing underneath. It's hard to move, right? From this point to X or y, right? But instead of x or y, if you can move up, if you can, turn or tilt your line upward, right, until there is only one point, tangent point, right, then the slope will be the largest. You can maximize the slope, right? In other words, you can maximize the return for risk. Okay? That's why we have this graph. This M happens to be a tangent point, right? And if you read the chapter, the chapter calls it market portfolio, and it gives the definition, one-line definition of market portfolio, right? But unfortunately, it doesn't give you any more detail, and it just takes, it requires somewhat deeper knowledge, understanding. So if I want to really explain this to you, it'll take another maybe couple of weeks. It's a high-level concept, financial concept. It has to do with the efficient market hypothesis, right? Why this tangent point has to be market portfolio, right? So for now, in this course, in this class, right, let's just say that's a tangent point. That's enough, right? Why it has to be the tangent point, right? Because the tangent point has the highest slope. It achieves the highest slope. And the slope, actually, this slope has a special name. It is called Sharpe ratio. Sharpe is a person's name, William F. Sharpe. He's a famous finance professor, finance scholar, okay? And he named this ratio the Sharpe ratio. Okay? So the tangent point will give you the highest Sharpe ratio, which means you get the most return for your risk taking. Okay? That's enough. Okay? So the line that connects this RF to tangent point and the extension of that line, this line is called the capital market line. Okay? And if you understand this concept so far, or this concept so far, then you will understand the idea that you don't have to, and you will not consider any other portfolio, right? Because this portfolio gives you the best combination, the most efficient combination, or it's not really. It sounds funny. It sounds incorrect in English, but this point, if this is tangent, right? M gives you the best efficient combination. Gives you the best efficient combination. Well, to be in English language, the better expression is actually the most efficient, right? But it's slightly different connotation. I mean, efficiency is efficiency. There is no more or less efficient combination, right? Best efficient combination means among all the efficient combinations, this gives you the best return, right? That's why we call it best efficient combination. Okay? The tangent point. Okay? And again, it happens to be the market portfolio, but you don't have to worry about that. Because if you take higher level finance course and learn about efficient market hypothesis, you can spend a lot of time, you'll probably have to spend a lot of time proving why this tangent point has to be the market portfolio. Okay? Yeah? Mm-hmm. X and Y? Yeah. No, because it depends on your preference.
But in this situation, can you say that M is
right, because X and Y have the same slope, same Sharpe ratio. So you cannot say which one is better, right? But you can definitely say C or M, the tangent point, is better than X or Y.
So you mean while we are getting closer to the tangent point,
Mm-hmm.
the points on the slope?
I'm sorry, what? Yeah, tangent point gives you the highest slope, right? Yeah. Right, that's right. Because the Sharpe ratio, again, the Sharpe ratio gives you the return for risk, right? Yeah. Oh, just 1 second. Let me. Okay, go ahead. Okay. Mm-hmm. Right.
For that case, can we take logic? So can we take invest in the point RF and N?
RF and N, M? Yeah, of course, right. So actually, that's the point I'm getting at. So give me just about 2 more minutes, okay? Give me 2 more minutes. So let me draw this once again. And we are talking about, let's say, M here, RF here. Yes, you can take any midpoint. You can, if you want, you can go 25, 75, 50, 50, right? You can take any combination, right? And I was saying, if you understand that, right, then you're not gonna take any other combination because all other combinations are inferior to this combination, this portfolio, or any combination of that, any in between of that, right? Again, this, let's say here's a combination portfolio Q, right? Then if you think about the Sharpe ratio, right? Sharpe ratio for Q is much better than Sharpe ratio for X or Y. Okay? So you will take any combination of this or this if you can only lend. Here's another concept here. Here's, it says lending, borrowing, right? So think about it. If you put 100% of your money to the T-bill, then you are lending 100% of your money to government, right? If you buy T-bill, government bond, that means you are lending your money to the government, okay? That's why it says lending, right? So if you are doing 50-50, that means you are lending 50% of your money to the government, and you are investing 50% to this portfolio, right? If you can borrow at the same rate, right? If you can borrow, let's say you have $1 million, right? So this is a $1 million combination, right? So you can, put entire 1 million here. That means you're not borrowing, you are not lending, right? If you put entire 1 million here, that means you're lending entire $1 million to government. Or if you can borrow $1 million from government or from someone at the same rate, let's say 3% rate, right? Then you can extend it, right? So let's say this portfolio includes 1,000 shares of Apple and 1,000 shares of AT&T, right? If you borrow $1 million, that means you can invest in 2,000 shares of Apple and 2,000 shares of AT&T, which means you can double your return on your money, right? And of course, risk will double because in the worst case, you'll lose entire $2 million instead of $1 million. Okay? That's the idea of lending and borrowing, right? So you can choose any combination on this line, capital market line, right? Make sure you try to understand that, right? Sorry I went a little over today, right? But why don't you read the chapter and see if you can understand the concept. Okay?